my name by now. For those that are new to this, my name is Mr. Mlenga Kunta, the science and mathematics teacher at Our Lady School in Lusaka. Today, we'll be looking at a thin lens. Today, we'll be looking at a thin lens. What is a thin lens? This is a thin lens that we'll be talking about. This is a thin lens that we'll be talking about. Then thereafter, we're going to look at the how to complete the ray diagram. Now, if you look at this lens so closely, let me remove it from the holder. Look at the cross section. We can depict that this lens at the center, it is thick, and at the edge, it is very thin. Look at it so critically. You find that this lens is thick at the center and thin at the edge. So that is what we can say for now. And the name of this lens is converging or convex lens. So we'll be looking at a thin converging lens. So this thin converging lens, remember I said this lens here is also called convex lens. So this lens is also called convex lens. It's also called a convex lens. Now, what can we say about it? We said this lens is thick at the center and thin at the edge. So this lens is thick at the center, and thin at the edge. Thick at the center and thin at the edge. You can see at the center is very thick, and then at the edge it is very thin. But now, what can you say about this? From the name of this lens, converging lens, this lens has got the capacity of when rays of light passes through this lens, they are made to meet at the same point. So the meeting of these rays, that's why we derive the name converging, because to converge is to meet at certain point. Now, we're saying that these rays that are passing through the center, these rays that are passing through the lens are made to meet at a certain point. So, but not all the rays that pass through this lens bend as they meet at a certain point. That ray of light that passes through at the center does not bend. The ray of light that passes through the center does not bend. So that's a very important point that we're going to start with. We're saying when rays of light pass through this the converging lens, they tend to meet at a certain point. We're going to know the name of the point where these rays meet. But the other important thing is that the ray of light that pass through the center of the lens the ray does not bend. The rest of them bend as they meet at a single point, but the ray that passes through the center does not bend. So let us see how we can understand this in the best way. So what we're saying, if we have a lens, this is if we have a lens, we want to have the lens in a vertical position. If this is a lens which is thick at the center and thin at the edge, if this is our lens. Now, we are saying the ray that passes through the center does not bend. So this ray which passes through the center this is our center, the center of the lens. This is the lens. This ray does not bend. But the rest of them all tend to meet when they pass through this type of a lens. Okay, so let us say they are meeting at that point. We are going to have a diagram drawn like that. We're going to have a diagram drawn like that. We're going to have a diagram drawn like that. Let's have a diagram. So we can see that all these rays that are passing through the center, all these that are passing through the lens are able to meet at a certain point, but except for this one here, very stubborn. This one passes through the center, it does not bend. Now, having looked at this, let us understand the points or the features that are found on this diagram, such as the center of the lens has got the name. Then this is a point where these rays are meeting. It is a point. This point also has a name. Then the distance from the center of the lens up to the point where these rays are meeting. This distance also has a name. We also have the name given to the line that is representing the ray passing through the center of the lens, which does not bend. So that is our next item. The features that are found therein. So we're saying the center of the lens, feature number 1, the center of the lens. This center of the lens, C, is called optical center. This center of the lens here, represented by C, has got a name we call the optical center. Then the other thing that we're going to look at is this line here. This line here, which is drawn, passing through the plane or passing through passing through the center of the mirror, also has a name. Okay, so this line which passes through the center of the lens has a name. So we are saying the line passing through the center of the lens is called principal axis. So this line, which is representing the ray of light that passes through the center, that line which represents the ray of light which does not get refracted when passes through the center, is called the principal axis. So look at the principal axis. Also looked at the optical center. Now, we also have, remember I said, we also have the name given to the point where these rays of light are meeting. The name given to the point where these rays of light are meeting, and that point is called the focal point. So we are saying the point where the rays of light meet after passing through the lens. The lens is called focal. Is called focal point. So the point where these rays, after passing through the lens, where they are meeting from, that is what we call the focal point. So the only thing now which is remaining is the distance. The distance from the center of the lens up to the focal point. This distance is called focal length. All right. Okay, it's called the point. Okay, just here. Let's say the point where the rays converge is called the principal. The point where these rays meet is not called the focal point. It's called principal focus. It's called the principal focus. It's called principal focus. All right. So now let's understand the distance between the center of the lens up to the principal focus, the point where these rays are meeting, and that point, the distance is called the focal length. The distance, the point where the rays of light meet after passing through the lens is called the principal focus. Now, the distance between the principal focus and the optical center, the distance between the optical center, which is the center of the lens, and the principal focus, that distance is called focal length. So we are saying the distance between the center of the lens, which is called optical center, and the principal focus. The principal focus is called focal length. All right, so the distance between the focal point, the optical center, the distance between the optical center, is the center of the lens, and the principal focus, that distance is called the focal length. But now, the other thing that we need to understand is the rules. There are certain rules that guide how these lines get refracted. There are rules that are given on how these rays get refracted. So what rules are they? What rules are they? There are about 3 rules that are very important. And from there, we're going to look at how these rules are followed. So we are saying there are rules that help us on how to construct rules applied. Rules that govern the diffraction of these lines. Now, remember, we're going to have the principal axis. We're going to have the principal axis. This is the principal axis. This is this lens drawn like that. This is our lens. Now, the distance between now we're going to have these points, the focal points. This is, we can call it F1. We can also, but the distance between the F1 and the distance between the F1 and the should be the same. Other books say 2F, other books say F2. So I'm going to say F1. So if you have this as a F2, and then this your F1, so we are saying what are these three rules that govern the completion of the ray diagram? There is that ray. There is that ray that moves. That is when the ray that is moving parallel to the principal axis meets the lens. So we're having this ray of light. We're having this ray of light that is meeting the center. How does it bend? It bends passing through the F1. So when this ray moves like that, it has to get refracted and passes through the F1. This ray has to pass through F1. So we are saying the ray parallel to the principal axis, the ray parallel to the principal axis gets refracted through F1. That's the first rule. The ray parallel to the principal axis, that passes, that gets, that is the ray parallel to the principal axis gets refracted by the lens passing through the F1. So the ray that is parallel to the principal axis, when it meets the lens, it gets refracted passing through F1. So that is the first line. The second rule is that the ray that passes through the center of the lens does not get refracted. The ray that passes through the center of the lens does not get refracted. So we are saying the ray passing through the center, the optical center, because we know it now, the optical center does not get refracted. It does not bend, does not get refracted. Does not get refracted. It does not get refracted. So this is the ray. Passing to the center of the lens does not refracted. So this is number 2. Rule number 2 is representing the ray number 2. Then the third one is that the ray that is passing through the F1 from the left, the ray that passes through the F1 from the left, meeting the top of the lens here, meeting the lens here, you find that it moves parallel to the principal axis. In short, it's the opposite of the first ray. The first ray, from the beginning, it is parallel, getting refracted, passing through the F1. But number 3 is going to pass through F1. Then it moves, it gets refracted, moving parallel to the principal axis. So we are saying when this ray passing through F1 meets the lens, it has to get refracted parallel to the principal axis. Number 3. So these are the most important rules, such that when it comes to completion of the ray diagrams, we are going to use these, but except that we just use 2. If you want, you can use rule number 1 and number 2. If you want, you can use rule number 3 and rule number 2. That is very, very important. There are 3 rules that are there. We're saying the first rule is that when the ray is parallel to the principal axis, passing through the center of the lens, it gets refracted through F1, goes that way. Then the second one is that the ray that passes through the center of the lens, which is called optical center, does not get refracted. And the third one, the ray passing through F1, meeting the lens, it has to get refracted, moving parallel to the principal axis. All right, so now we're going to look at how do we complete the ray diagram. How do we complete the ray diagram? There are about 5 or 6 situations. The first situation is when you put an object between the center of the lens and the optical, when you are between the F1 and the optical center, the center of the lens, where does the image gets? Where does it get formed? Where does it get formed? And what are the properties of the search of that image which is formed? So we are going to be looking at the completion of ray diagrams. Completion of ray diagrams. Completion of ray diagrams. That is the last part for today. How to complete the ray diagrams. Completion of ray diagrams. Completion of ray diagrams. How? First thing is, where does the image get formed? When you have an object positioned between the optical center and the F1, where does the image get formed? So the first scenario is an object between, I'll use BTN, the object positioned between the optical center and the F1. The object positioned between the optical center and the F1, where does the image get formed from? This is our optical center, remember? This is our optical center. And this is representing the lens. This is representing the lens. Representing the lens. This is representing the lens. All right. Now, let's demarcate the F1 and the F1 and the F2. Let us demarcate the F1 and the F2. Demarcate the F1 and the F2. So this is our F1. This is our F2. This is our F1. This is the optical center. This is our F1 on the right, and this is our F2. Be reminded, for you to get an accurate diagram, these distances must be the same. If you maintain 4 centimeters here, even here must be 4 centimeters, even here 4 centimeters, 4 centimeters. If the distances are different, be assured that the diagram is going to be wrong. So how is it going to be? Now we are saying we are having an object positioned between the optical center and the F1. So our center is somewhere here. Now, if you get to have an object positioned somewhere here, but okay, let's get to have the size of the image equal to the height of the lens from the center. So we're going to have this is our object standing upright. That is our object. So now let us see how that is going to have the image formed. So once you do that, you will find that the image that will be formed will be in such a way that, so when you draw, remember the first one was saying the line passing through the passing must be parallel to the principal axis. So this is the ray passing. It is parallel to the principal axis, then it gets refracted passing through the F1. This is the first rule. This is our ray. The second one is that the ray passing through the center does not get refracted, so it won't get refracted. And the third one is, we're saying this ray now has to move from, because we said if it is beyond this side, it has to pass through F1. It has to pass through F1, then it moves parallel. But this line has to move from the top, has to move from the top of the lens, from the top of the object, passing through the center of the lens. So the line drawn from the top of the object, passing through the center of the lens. This is a line. This is a line which doesn't get refracted to go that way. But you find that these lines are not meeting. Can you see that? So if these lines are not meeting, therefore we have to extend the lines upward. We have to extend our lines upward in a hidden, detailed manner. So we're going to extend. Let me just clear here. We're going to extend our lines, this one and that one, in hidden, detailed manner. So these are our lines. The other one is this. So when these two lines are going to meet, will tell us the position of the image. So the image is being formed exactly at F1. You can also see that. So the image is being formed exactly at F1. All right.